Hello, and welcome to Ships of War, the Warship History channel. We explore both the most famous naval history and the history too often forgotten. Because every ship has a story worth telling. And today, we're stepping into a moment when naval engineering was pushed to its edge. When limits forced innovation and simplicity gave way to complexity. And the result was a different way of thinking about firepower. Fewer turrets, more guns. The quadruple turret. Following the Washington Naval Treaty, the era of unrestricted warship construction ended, replaced by a regime of strict, unforgiving tonnage limits. Every ton now carried immense strategic weight, yet naval expectations remained as ambitious as ever. Designers were still tasked with delivering heavy-caliber guns, impenetrable armor, and high speeds, all squeezed into a fixed displacement. Each traditional turret demanded massive armor plating and deep heavy barbettes that further dictated the length of the ship's armored citadel. Adding more turrets caused weight to climb exponentially, more weight required more armor, which in turn cramped internal space and forced compromises across the entire vessel. British and French designers eventually reached an uncomfortable realization that if the number of guns could not be reduced, then the number of turrets had to be. This sparked a radical new question: what if the same firepower could be condensed into fewer, more complex turret systems? By packing 4 guns into a single mounting, naval architects could finally shrink the armored citadel and slash the total weight of the ship's protection. On paper, it was a masterstroke of engineering, a concept that promised more firepower and better armor, all within the strict limits of international treaties. To the designers of the British King George V-class and the French Richelieu-class, it looked like the undeniable future of the sea. But a quadruple turret was never just a bigger box for guns, it was a sprawling, temperamental ecosystem. In a simple twin turret, each gun operates with its own space and independence. In a triple, the machinery begins to overlap and the coordination of hoists and safety locks becomes a delicate dance. When you move to 4 guns, that complexity doesn't just grow, it explodes. Every ammunition hoist and loading tray must work in perfect synchronization, or the entire machine grinds to a halt. The idea of quadruple turrets was not uniquely French or British. Designers across the world arrived at the same conclusion. Fewer turrets meant a shorter armored citadel, less weight in barbettes, and more displacement available for armor and speed. And so, on drawing boards from Europe to the Pacific, quadruple turrets began to appear. The Italian studied them during early design work for its fast battleships, before ultimately settling on triple turrets for the Richelieu-class battleship. The Americans also examined similar concepts during preliminary studies in the interwar period, but rejected them in favor of triple turrets on ships like the North Carolina-class battleship, prioritizing reliability and simpler machinery. In the end, many navies reached the same conclusion. Quadruple turrets offered clear theoretical advantages, but they came with engineering risks that not every navy was willing to accept. Only a few would even design the quadruple turret system. And fewer still would carry it into war. The French took a pragmatic, almost cynical approach with the Richelieu-class, embodying the naval adage that the French copy nobody, and nobody copies the French. They did not view their quadruple turret as a single, unified system, but rather as 2 independent twin turrets forced to live under the same roof. A thick armored bulkhead split the interior in half, giving each pair of guns its own dedicated machinery and shell rooms. It wasn't the most elegant solution, but it was incredibly robust. If a shell strike or a mechanical failure knocked out one side, the other half could keep firing. It was a design built for the messy reality of the battlefield, indifferent to the conventions of other nations. The British, meanwhile, pursued a vision of mechanical perfection for the King George V-class. They designed an integrated system where every gun could, in theory, operate independently through a web of complex interlocks and automated safety cycles. It was meant to be the pinnacle of efficiency and flexibility, a quintessentially British attempt at total engineering control. In reality, the design was so tightly wound and the timing so critical that it became a mechanical nightmare. Because the system was so deeply interconnected, a single jam or a slight misalignment wouldn't just stop one gun, it often paralyzed the entire turret. In the heat of battle, this pursuit of sophistication frequently turned a technological marvel into a silent, armored liability. Despite their early problems, these systems were not static failures, they were evolving. Lessons from early breakdowns were studied in detail. Interlocks were refined, tolerances improved, and crews became increasingly skilled at operating and maintaining these complex machines. What had once been fragile and temperamental was gradually becoming predictable, even dependable. In both British and French service, quadruple turrets began to show something important, not perfection, but progress. Just as these complex systems began to reach their maturity, the nature of naval warfare underwent a fundamental transformation. The aircraft carrier rose to dominance, extending the reach of naval power far beyond the horizon, and far beyond the range of even the heaviest naval guns. Attacks could now arrive from any direction, at any time, in overwhelming numbers. Suddenly, the battleship was no longer the centerpiece of the fleet. The tactical advantage of squeezing more guns into fewer turrets, once a matter of survival, lost its urgency. It is a common misconception that quadruple turrets failed. In truth, they were actually succeeding, problems were being solved, and the designs were becoming more reliable with every iteration. But they were the answer to a problem that was rapidly disappearing. They were a product of treaty limits and weight restrictions, a quest for maximum firepower within a constrained frame. By the time the answer was finally refined, the question had changed. Ultimately, quadruple turrets did not become obsolete because they didn't work, they became obsolete because the battleship itself was no longer the decisive weapon. It wasn't the turret that had reached its limits, it was the ship it was built to serve. A vanishing philosophy. With that shift, a deeper philosophy began to fade. For decades, naval power had been defined by a single, unshakable idea. That strength lay in the ability to deliver the heaviest blow at the greatest range with the greatest accuracy. And that brings us to the end of the story. A story not just about turrets or ships, but about how quickly technology can outpace the ideas it was built upon. If you enjoyed this video, consider leaving a like. It really does help more people discover the channel. And if you want more stories like this, grounded in real engineering, real history, and the decisions behind these machines, subscribe to the channel. Thank you for watching.